The question number 36 is that two guitar strings A and B are slightly out of order and produce beats of frequency 4 Hz. When the tension in string B slightly decrease, the beat frequency is found to be 3. The frequency of A is 516. And what is the original frequency of? See, the frequency of A is given 516. That is fixed. Now with B, there are 4 beats heard. So 4 beats, either it can be more or less than this. So it could be 520 Hz or 512 Hz. Now it says that when the tension is slightly decreased, if you decrease the tension, then frequency will decrease. So if it would have been this one, it would be like this, or this could be like this. Depend upon how much tension you are reducing. This value will go down and this value go down like this one. Now what he says that when sounded with this one, you get 3 beats now because this is fixed. And see, out of this charge, here you get 3 beats. That means now it has frequency of 519, and when the tension was reduced, and prior to this, the frequency was 520 Hz. Therefore, the original frequency of B was 520 Hz, and you reduce the tension, it goes to 519. With 516, you're getting 3 beats. So correct option is option number 1. The question number 37 is a tuning fork of frequency 400 Hz resonate with the tube closed at one end of length 20 cm and diameter 6 cm in fundamental mode. The velocity of sound. Let's see the solution. Whenever the diameter is given, so there is some end correction. And let's how to calculate the end correction. So end correction is 0.3 into the diameter. And diameter is given 6 cm, so 0.3 into 6, that is 1.8 cm is the end correction. What does it mean? This was the resonance tube. When the diameter is given, one node is formed here, the antinode will be formed here, and this is E because of edge effect. So sound goes like this, and from resonance it comes back. Now, how much is the distance between antinode and node? That is equal to lambda by 4. Now lambda by 4 in diagram is equal to length of this plus the end correction. And what is length of the tube, which is given to you 20 cm, end correction is you calculated 1.8, so it is 21.8 cm. So what is lambda? Lambda is equal to 4 into 21.8 cm. Now the frequency of the fork is given 400 Hz. Then what is V? V is equal to N into lambda. So V is equal to 400 and lambda is how much? This you have 4 into 21.8 divided by 100. So cancel with 4, so 16 into 21.8 meter per second will be the frequency, which is equal to 348.8 meter per second. So the correct option is option number 3. Now the question number 38 is a standing transfer wave is generated in a string clamped at its both ends, whose equation is given as y is equal to 6 sine of 2 pi by 3 into x cos of 120 pi t. X and y are in meter and t in second. The separation between a node and next antinode. So this is a stationary wave equation and separation with node and antinode. And that separation is always lambda by 4. Now if this equation is given, then this is y is equal to 2a sine of kx cos omega t. Then what is k? K is equal to 2 pi by 3 and k, this is equal to 2 pi by lambda. So therefore lambda is equal to 3 meter. So what is the distance between the node and antinode? That is equal to lambda by 4, that is 3 by 4 meter, and 3 by 4 into 100 centimeter, and that is equal to 75 centimeter. And look, the option 4 is 75 centimeter. So the correct answer is 4. Now see the question number 39. An earthquake generates both transverse and longitudinal waves in the earth. The speed of transverse wave is about 6 km per second, and that of the longitudinal wave S is about 12 km per second. A seismograph records T and S waves from an earthquake. The first S wave arrives 3 minutes before the first T wave. The epicenter is located at the distance of about, see, this is the epicenter from where the waves are generated, and the seismograph is at this place, which is an observation center. Now both types of waves are coming. One is the transfer waves, and second are the longitudinal waves. And let's say this distance is d, and the d will be equal to the velocity of into ts, and d will be equal to the velocity of the transfer waves into the time of the transfer waves. Now the time difference is recorded between the two. And what is the time difference? The time difference is the time taken. The speed of the s wave is higher, so it will take lesser time, and the speed of s wave is less, so it will take longer time. So this would be dt minus ts. And time is distance divided by the speed, and the speed was equal to 6 km per second, and d and the speed was 12 km per second. So I take t out, and this is 1 by 6 minus 1 by 12, and that is equal to d divided by 12. Now what is the time difference given? The time difference is given 3 minutes, and total in second, 3 into 60 second is equal to d divided by 12. This is in kilometer, so d will be equal to 12 into 3 into 60, and that is equal to 2160 kilometer. So from epicenter, from where the waves are generated, till the observation center of the seismograph, the distance is 2160 kilometer. So option is the 4. The question number 40 is the persistence of the sound in a hall is called. See, the reproduction of sound, that is multiple echo, and the multiple echo is called the reverberation of the hall. So the correct option is the 3.